In general, as the angle of attack increases, lift and drag increase up to a point where lift decreases abruptly and drag becomes the principal component. This is known as the stalling angle. From this angle to 90 degrees, drag continues to increase while lift falls off. At 90 degrees, the airfoil acts like a flat plate. It has maximum drag and negligible lift. Wind tunnel tests have also proven that for any given airfoil, lift and drag vary directly with the area of the wing. If the area is doubled, lift and drag are also doubled. Lift and drag vary directly as the square of the velocity of the relative wind. If wind velocity is doubled, lift and drag are multiplied by 4. Lift and drag are directly proportional to the density of the air passing over the airfoil. If air density is doubled, lift and drag are also doubled in value. Expressed as an equation, the lift is equal to a coefficient which is determined by the angle of attack and shape of the airfoil, multiplied by the density of the air, multiplied by the area of the wing, multiplied by the velocity of the wind squared. Drag equals the coefficient which is determined by the angle of attack and shape of the airfoil, multiplied by the density of the air, multiplied by the area of the wing, multiplied by the velocity of the wind squared. When an airplane is flying horizontally at a constant velocity, the forces acting upon it are in equilibrium. The retarding force, or drag, equals the propelling force, or thrust. The lift must equal the total weight of the airplane. Therefore, the lift and drag equations serve to determine how much weight an airfoil will lift under certain conditions and how much thrust horsepower is required to overcome the total drag of the airplane. The air pressure at various points on an airfoil is measured in order to determine the airfoil's efficiency or its suitability for a given purpose. The measurements are made by building into a model airfoil small copper tubes which are sealed flush with the surface of the model. These tubes extend from the model to a pressure measuring device outside the tunnel. The device is called a manometer. This figure illustrates its principle of operation. The liquid in both the tube and the reservoir will be at the same level as long as the pressure in both tube and reservoir are equal. If by any means, such as this plunger, for example, the pressure in the tube is increased, the liquid is forced into the reservoir, lowering the level in the tube. If pressure in the tube is decreased, the liquid rises above the level of the reservoir. In a device such as this, if the liquid in the tube is subjected to varying pressures, the level will rise above or fall below the level of the liquid in the reservoir as the pressure is decreased or increased. Reading of liquid levels provides an accurate means of determining pressure differences. Additional tubes may be added, each connected to a different value of pressure, and each will indicate that pressure accurately, regardless of pressures in the other tube. Operating on these principles, this bank of manometer tubes is used to determine pressures on an airfoil. Because all tubes are at the same pressure, being exposed to the atmosphere, the levels in the tubes are equal. For test purposes, each manometer tube is connected to a different point on the surface of the airfoil. The majority of these test points are located on the leading edge and upper surface. Relatively few are placed on the lower surface. Of course, this is only a schematic representation of the connection. In actual practice, tubes run from the manometers through an opening and inside of the airfoil to the test point. Atmospheric pressure is usually taken as the reference level. Pressures above atmospheric are called positive. Those below atmospheric are called negative. Actually, these values are pressure differences with reference to the atmospheric pressure. With reference to absolute zero, all pressures are necessarily positive. The model airfoil is placed in the test section of the wind tunnel. It is supported by wires which will transmit its lift and drag forces to the scale.